The famous, or rather infamous, potato problem. 2017, AB, free response. Number 4, calculator inactive. Let's go. At time t equals 0, a boiled potato is taken from a pot on the stove and left to cool in a kitchen. The internal temperature of the potato is 90 degrees Celsius at time t equals 0. Good to know. The internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. Little things like this are going to come in handy later, so read carefully and reference it later if necessary. The internal temperature of the potato at time t minutes can be modeled by the function h. They did not give you h, but it does satisfy this differential equation where h of t is measured in degrees Celsius and h of 0 equals 91. H of 0 equals 91 was said to us right here in this sentence. Okay, part A, write an equation for the line tangent to the graph of h at t equals 0. Okay, I believe I can do that. And I believe you can too. Number 4, part A. And when we're dealing with the equation of a tangent line, then we're going to need the slope and we're going to need a coordinate as well. So normally I'd say y minus y1 equals mx minus x1. I'm not. I'm going to go about it a little bit differently, but let's just go ahead and start with what we do know. This is going to happen at t equals 0. So t equals 0, the temperature, h for hot, I guess, is 91. And we need to know the slope at that specific time as well. So we're going to find the value of the derivative, which they gave us. They have a differential equation at t equals 0. So negative 1/4 h minus 27. Okay, I'm looking right here on the paper. H minus 27 will, h at t equals 0 is 91. You could say h equals 91. So 91 minus 27, and then we'll figure out what this is, and we do need to go ahead and figure out what that actually is, and it's going to be pretty straightforward. 91 minus 27 is going to give me 64, so we have negative 1/4 times 64. That's going to give me negative 16. So here's the deal. We have our coordinate, we have our slope, and I would do y minus y1. I'm not, again. I'm going to do h minus h1 equals slope. T minus T1, T sub 1, but basically the temperature they gave me, or the time they gave me. All right, we can solve that because we also need to approximate the internal temperature of the potato at time t equals 3. So normally you could leave it like this, but we can solve this pretty easily. So h equals negative 16t plus 91. And that is our tangent line. This one is also a valid tangent line, but this one's going to be more practical for the next thing when we have to approximate the internal temperature of the potato at t equals 3. So at t equals 3, then we have negative 16 times 3 plus 91, which is going to give me negative 48. Negative 48 plus 91. Which is going to be 43 degrees Celsius. Okay, that takes care of part A. Part B. Use the second derivative to determine whether your answer in part A is an underestimate or overestimate of the internal temperature of potato at time t equals 3. Easy to get overwhelmed in that. Let's just start by finding the second derivative. And I'm going to write the first derivative that they gave us. So dh dt equals negative 1/4 h minus 27. We're going to find the derivative of that. So when we take the derivative of that with respect to time, then we will basically take the derivative of this. So if it helps, you could do negative 1/4 h and then plus 27/4, totally valid, and we'll just take the derivative of each term. The derivative of negative 1/4 h would be negative 1/4. The derivative of 27/4 is 0. It is tempting to stop here. No, don't, okay? Don't be like, oh, well, it's negative 1/4. It's not. It's not only negative 1/4. You are taking the derivative with respect to time. This is implicit differentiation. So because you took the derivative of h with respect to time, you needed the derivative of h with respect to time. So then we'll keep going. We have negative 1/4 times dh dt. Well, dh dt is this or this. I'm going to use this one. So negative 1/4 times negative 1/4 times h minus 27, a lot of parentheses going on. And if you wanted to, you could simplify that and call it 1/16 h minus 27. Feel free to distribute as much or as little as you would like. This is going to be practical to leave it like this. So let's read the question again, part B. Use the second derivative, found it, to determine whether your answer in part A is an underestimate or an overestimate. Okay, here goes. Tangent lines can, bear with me now, overestimate or underestimate. Ooh, that's tragic. Oh, it's getting worse. No. Depending on concavity. This is concave down, and this is concave up. So now the question really is, when I plug in the appropriate h value, and we'll figure out what that is in a minute, but when I plug in the appropriate h value, do I get this situation or this situation? This can happen in your head. This visual can totally happen in your head. Okay. The internal temperature of the potato at time t equals 3. Well, if I'm going to plug in the time t equals, the temperature at time t equals 3, I need the h value that goes with 3, right? Okay, you can read this all day, you'll never find it. You will know the value of the temperature of the potato, internal temperature of the potato at t equals 0, but you'll never know what it is at t equals 3. But that's okay. Let's reread. The internal temperature of the potato is greater than 27 degrees Celsius for all times greater than 0, which 3 is included in that, of course. So what I do know is that the temperature here will be greater than 27. So because this is 27 or greater, we have a positive times a positive, so we're going to have a positive. Okay? And it might behoove us to really express why that is. So use this equation to approximate the internal temperature. Determine whether your answer in part A is an underestimate or overestimate of the internal temperature. Let's justify that. Did they say so? No, but I'm looking at the scoring guideline and it says you have to have a reason with it. So don't just throw it out there and be like, yeah, whatever. Okay, so this is true because the temperature is greater than 27 for all times greater than 0, because you can't travel back in time. So yeah, time has to be positive. We haven't invented a time machine yet, but I plan on inventing one yesterday. Anyway, moving on. Because, second time I've used that word lately, because the second derivative is positive at t equals 3, and actually for any t value that's valid. Okay, because the second derivative is positive, here we go, back to our little visual. We have a concave up situation, and the tangent line would be under the actual curve, so we have an underestimate. The tangent line approximation is an underestimate. Now, it's tempting to say, oh, greater than would be an overestimate. No, you gotta have the visual in your head when you do that. Okay, let's move on to part C, and I am going to use a separate piece of paper because I don't have enough room. C is going to take some space. So here goes. For t less than 10, an alternate model for the internal temperature of the potato at time t minutes of the is the function g that satisfies this differential equation, where g is measured in degrees Celsius and g of 0 equals 91. Let's kind of stop and think about what just happened. Don't stop too long, clock's ticking, but they are giving us an alternate model. Alternate model of what? The temperature of the potato. Now, at this point, you're probably sick of the potato and you never want to see another potato as long as you live, but nevertheless, we have one particular model of the temperature that was h, and now we have another one that's g. So we can have different equations that would represent the same thing, and they're both they're modeling it, they're approximating it. where g is measured in degrees Celsius and g of 0 equals 91. Not the first time you've seen that particular initial condition. Okay, write an expression for g of t. Stop right there. We are going to solve this differential equation. We're going to have to integrate by hand. This is calculator inactive. Based on this model, what is the internal temperature of the potato at T equals 3? So we're going to have to anti-differentiate that thing, and then we're going to use that anti-differentiation. So here goes. Part C asks us to find the function g, which is not necessarily the same as h. I'm going to be careful that my g's don't look like 6s. Go. And we are going to separate our variables. Always a good place to start. So let's get all our g's on the left, all our t's on the right. So as we do this, let's divide by this stuff right here. I'm going to leave the negative on the right side. I just find it a little bit easier. We're going to bring the dt up, multiply by dt. We're going to divide by g minus 27 to the 2/3, which if you want to get technical about it, you could call it g minus 27 to the negative 2/3. And then we'll have dg, right? And then we're going to integrate. All variables are separated. All our t's are on the right, all our g's are on the left, and we're going to integrate. That's going to give us negative t plus some constant. We don't know what the constant is. We won't put a constant on this side. This constant will absorb all the constancy we need. And there's a little bit of u substitution that's going to happen here. And it's not going to be too tricky. But I do want to write out the process just in case you need to see it. So if I'm going to do this and not take a bunch of steps over here, I'll do it over here. So g minus 27 to the negative 2/3 dg. Okay, well, u is g minus 27. The derivative of u would be 1 dg. That sounds good to me. So we're really dealing with the integral of u to the negative 2/3 du. And we're going to do the antiderivative of that. So we'll add 1 to negative 2/3. And we're going to get positive 1/3. Something times 1/3 will give me 1. That must be 3. And then plus c, not going to worry about it, it's built in over here. All right. So we have now integrated that. And I'm going to bring that over here. But instead of u, I'm going to put g minus 27. So we have 3 and then g minus 27 to the 1/3. So cube root of that, basically. Okay, at this point you might be tempted to solve for g. You wouldn't necessarily be wrong, but in my experience I have found it easiest to stop right here once you've integrated and use the initial condition to find c. Because if you don't, then when you divide by 3, you'll have to divide c by 3, and then you'll have to cube, and you'll have to cube all that, and it's too much. I'm going to just go ahead and say everything I know. I know that g of 0 equals 91. So using t as 0 and g as 91, we'll proceed and we'll find the value of c. So here goes. Sometimes I do this. I don't know why. It's fun. It's like a different idea. So 91 minus 27. We're going to raise that to the 1/3 power equals negative 0. That's pointless. Plus c. And so c equals whatever happens here. So 3 times... Okay, 91 minus 27 is 64. We're going to raise that to the 1/3. That is the cube root of 64. 64 to the 1/3 is going to give me 4. We have 3 times 4, which is c. So c is equal to 12. Fantastic. Now we're going to resume with this idea, and we're going to find the actual function itself. So that's the sound you make when you draw those awkward waves. So 3g minus 27 to the 1/3 equals negative t plus 12. Solve this thing for g. Here goes. We will divide by 3, and then we're going to cube it, and then we're going to add 27. Let's do a whole bunch of steps at once, okay? So g of t equals all this stuff divided by 3. So negative 1/3 t plus 4. And then we would have to cube that to get rid of that 1/3, and then we would add 27. So this is it. This is the value of the function. This is the function itself, which is what they asked for. They said, find g of t write an expression for g of t. And then, let's answer the question. Based on this model, what's the internal temperature of the potato at time t equals 3? Now we'll solve this. And so, one more random idea. You don't have to break up your work like I am. I just like to do that. We're going to put 3 in for time. So 3 minutes have passed. I wonder what the temperature of this potato is. At this point, I don't care anymore. I just want to eat it. Just throw it out because I'm sick of talking about it. -1 plus 4, that'd be 3. So 3 cubed plus 27, that's 27 plus 27. So 54 degrees Celsius is the temperature of the potato. Done. All right, let's grab a scoring guideline. And start over with part A. Here we go. Did we find the slope, which they got to be -16? Yes, we did. We earned a point. Did we get the equation of the tangent line, which they got to be y equals 91 minus 16t? 91 minus 16t, yes, I used h, they used y, that's okay. And the approximation is 43 degrees Celsius, and it is. Yeah. All right, part B, 1 point. 1 point for part B, that's it. All that work, that was it. Underestimate with the reason. You have the underestimate but no reason, or you have the reason but no underestimate, then sorry. But basically, there it is. There's all the work, the same stuff we did. And the graph is concave up for t greater than 0. Thus, the answer in part A is an underestimate. I don't think I used the phrase concave up. Would I get points for that? I'm going to say yes, but to be consistent, I'm going to say that H is concave up. I should have put that up here. It was implied. Maybe I should have said it a little more directly. All right, and then part C, 5 points here. Separation of variables. Did I separate my variables? Indeed I did. I split my G's and my T's. Did I take antiderivatives? Yes, I did. Did I use a constant of integration and use the initial condition? Constant of integration plus C, use the initial condition. I did, got that. And then I need the equation involving G and T, which we got right here. And then we got G of T and G of 3. Well, the equation involving G and T, which I think we could get credit for this. And then another point for this one that corresponds to that right there. And this is correct. 54 degrees Celsius is correct.